Okay, so looking at number 2 on today's worksheet, we identified the transformations. Now we'll start to use those in terms of the graph. So I need a vertex in quotes because it's not really a vertex like a parabola has a vertex. But I mean, what's the vertex?
2, 1.
Good. So right 2, up 1. Right 2, up 1. And remember, that's not, I don't even like that it's called a vertex. It's better called the new origin or the new starting point, something like that. That's where we'll center our graph at now. I think you could call it the center even, because it is the center of the graph. So again, vertex, I get it, because that kind of matches with parabola language and moving things around, but it's not really the vertex of anything. Okay, the vertical asymptote and horizontal asymptote both go through the vertex, or through the new origin. They don't have to be different colors, obviously, but so, Abigail, what is the equation for the vertical asymptote?
X equals 2.
X equals 2. And Noah, how about the horizontal asymptote? Y equals 1. And then, related question, Keegan, how about the domain? I grabbed the pink highlighter. That's if you want to be fancy, yes, but you can also give me the unfancy description of what X can or can't be. Yes. So Keegan opted for the fancy version. What's the unfancy version? X can't be 2. And I'm okay with either one. Right? So like the fancy version is nice because it's fancy. The unfancy version is nice because it's simpler, just to just say X can't be 2. Do we know why X can't be 2? Not from the graph, but from the equation. How do we know that X can't be 2? What would be undefined? Yeah. You can't divide by 0, so even just looking at the equation, we know that X can't be 2. And doing it that way was what will help us tomorrow. So tomorrow we'll have to start with the equation to get the asymptotes rather than draw the asymptotes and then write the domain. But it's related to the fact that you can't have 0 in the bottom. Jeremy, how about the range? Y can't be 1. And again, you could write that fancy style if you wanted to. And I'm glad that we worked out that we did one fancy and one not fancy. It's just a good reminder.
What happens if you put 1?
Well, so that's, you mean like how do we know Y can't be 1? That's a little bit harder. It's real easy to see why X can't be 2. It's not real easy to see why Y can't be 1. We're not really there yet. That's sort of a result that we don't know where that came from yet. So it's a good question, and I'm not ready to answer it yet. Is the short answer. Okay, now it's time to graph. Although I need to be careful because I need to still think about flipping and stretching. 1, 1 and -1 are our usual points, our parent function points. But there's a -3 out front. So I need to take that -3. And who gets the -3? The Y values. So that -3 will accomplish the flip and the stretch all at once. Again, some people don't do this. They just I don't know, instinctively is not quite the word, but they just know to flip it and stretch it, and they just stretch it by 3. And that's fine. Others of us want to take our time and slow it down a little bit. So instead of going over 1, up 1, I'm going to go over 1, down 3. And back 1, up 3. So it's only 1 point like per branch, but I do have the asymptotes there to help me sort of guide where this graph is going. And then we should take 10 seconds when we finish to sort of just verify that all these transformations we said, we remembered to do them. Up 1, right 2, we got that. It's flipped over, and it's stretched out. So I feel good about that answer. Again, with graphs, almost everyone gets the transformations correct. And then sometimes, even though they wrote out the transformation, it didn't show up in their graph. And if you would just take a time at the very end to verify that you accounted for all the transformations that you knew were there. Okay, your assignment is the odds, but do number 1, and then we'll walk through number 1 kind of quickly, and then I will leave you alone. So try number 1, and then we'll do a bunch of popsicle sticks for 1. I will shut my mouth and let you continue. I think I see 3 transformations there. Madison, what's one of them? All right, stretch by 3. Ava, what else is going on? Left 2. And Dylan, what's that last thing? Down 1. So the combination of all those things puts my vertex where, Carter? -2, -1. And again, vertex, I don't like that word, but that's what's printed there. So -2, -1. -2, -1. There's my new origin, my new starting point, the center, vertex, if you want to call it that. Ella, how about the vertical asymptote? X equals -2. Good. Benji, how about the horizontal asymptote?
Y equals -1.
Y equals -1. Good. Andrew, how about the domain? X can't be -2. And tell me from the equation, Andrew, how you know that X can't be -2. Yep, can't have a 0 in the bottom. So that's why X can't be -2. Karis, how about the range? It can't be -1. Okay. Now I just need to worry about this stretch. I saw this on a bunch of papers walking around. So you take that multiplier out front and multiply the y values to accomplish the y stretch. So 1, 3 and -1, -3. Again, from the new origin, not from the real origin, but from your shifted origin. And then use the asymptotes. So you get closer and closer to each asymptote. And there's my picture. Quick word of caution. Most of you are fine, but some of you get a little bit ahead of yourselves, or you get going too quickly, and you put a dot there, and you're just like that as a graph, and that as a graph. And I'm going to take off if I see that, because that's not like recognizing what the asymptotes are there for. You're supposed to be getting closer and closer to the asymptote. So if you curve up, you're not doing that. So I know that may seem minor, but slow down and use those asymptotes. Don't just put a little U in there. And basically, now that I've warned you, now I don't feel bad when I take off a point on the test. Or more importantly, now you won't do it anymore because you'll be careful and just slow it down a little bit and do a nice graph rather than just a quick little U thrown in there. Okay, so today the rest of the time is yours to finish the rest of the odds. So that's 7 problems in 30 minutes. I think you can probably finish that. Most of you are halfway done already.